Question 2. This question is about sodium fluoride, NaF. Some toothpaste contains sodium fluoride. The concentration of sodium fluoride can be expressed in parts per million, ppm. 1 ppm represents a concentration of 1 milligram in every 1 kg of toothpaste. The 1 gram sample is found to contain 2.8 times by 10 to the power minus 5 mol of sodium fluoride. Calculate concentration of sodium fluoride in ppm for the sample of toothpaste. Give your answer to 3 significant figures. It's a pretty tricky question. This whole of question 2 is pretty tricky, in my opinion. But that's exactly why we need to go through it. So if a question like this, similar comes up to it, at least we've gone through a similar type of question through it. And so we are slightly more prepared, or we're prepared. So we know a 1 gram sample of toothpaste contains 2.88 times by 10 to the power minus 5. It's given in the question, but I just want to write it down, of NaF. And now I can move on from here. So what the first thing we want to do is let's find out the moles of NaF. Moles is equal to what? Well, in this case it's going to be moles is no, sorry, not the moles of NaF, the mass of NaF. You know, moles is equal to mass over mR. Mass can be the moles times by mR. 2.88 times by 10 to the power minus 5 times by the mR of NaF. Well, Na is 23, F is 19, so it's going to be times by 23 plus 19 in brackets. That will give me 1.21 times by 10 to the power, that should be 5, a bit clearer. 1.21 times by 10 to the power minus 3 grams. Okay, now we know that what do we want to find? Well, we want to find it in, 1 ppm represents a concentration of 1 milligram in every 1 kg of toothpaste. So we want to get into milligrams, so we want to, well, to grams to milligrams, we need to times by 1,000, and from milligrams to grams, we divide by 1,000. So we want to do 1.21 times by 10 to the power minus 3 times by 1,000, and we get 1.21 milligrams. So we just get rid of the 10 to the power minus 3. Now this is the mass of NaF, milligrams in 1 gram. Worked out the grams, and that's milligram in 1 gram. We want to find it in a kilogram, so what we want to do now is times it by 1,000. That will give me 1210 milligrams in 1 kg, because that's what we're trying to find. A milligram in every 1 kg of toothpaste, and that's what 1 ppm is. And therefore we get an answer of 1 to 1 milligrams, and that is what 1210 ppm, parts per million. And then it says 2.2, sodium fluoride is toxic in high concentrations. Major health problems can occur if concentration of sodium fluoride are greater than 3.19 times by 10 to the power minus 2 grams per kilogram of body mass. To reduce the maximum mass of sodium fluoride in grams that 75 kg person could swallow without reaching toxic concentration. We know this much per kilogram of body mass. If it's if the concentration is greater than this per body mass, then major health problems happen, therefore it's toxic. So if we want to find a maximum mass that a 75 kg person could swallow without reaching toxic concentration, all we have to do is do the maximum per kilogram body mass, because remember it says if concentrations of sodium fluoride are greater than this, then major health problems can occur. So 3.1 times by 10 to the power minus 2 grams, and we want to find it in milligrams. So we are going to times by 75, and we're also going to times by 1,000, get into milligrams, and that will give me 2390. Therefore 3390 is the mass of sodium fluoride in milligrams. 2.3, the concentration of sodium fluoride in a prescription toothpaste is 2800 ppm, parts per million. Use your answer to question 2.2 to reduce the mass of toothpaste in kg that a 75 kg person could swallow without reaching the toxic concentration. So, the concentration of sodium fluoride in prescription toothpaste is this. Okay, and we know that mass of sodium fluoride, that the maximum mass of sodium fluoride without reaching a toxic concentration of 75 kg per person is 2390. So if we wanted to deduce the mass of toothpaste that a 75 kg person could swallow, all we have to do is 2390 divided by 2800, and that will give us the mass of toothpaste in kilograms. 2390 divided by 2800, 0.854, which give me 0.854 kg. I just also write it here, because why not? And then 2.4, identify the diagram in figure 2 that shows the correct relative sizes of the ions in sodium fluoride. Well, negative ions have larger ionic radius compared to positive ions. Now if we just use that that statement, the answer is B. Just using that, because it said negative ions have a larger ionic radius compared to positive ions, which is true. And I just put that. It's not like a quote you have to remember of chemistry, but it's just a key fact you should know. Negative ions have larger ionic radius compared to positive ions. Obviously, you've got +1 or -1. This A is showing us the same size, is not correct, and then C is showing that Na plus is bigger. I don't think I think students will most go for C. I went for C when I first attempted this question today, in a while, but the answer is B. Reason being, well, we know Na plus, first things first actually, Na plus and F minus. Na plus, F minus. Na plus, so 11 minus 1, so we're going to have 10 electrons. F minus would be 9 plus 1, so we're going to have 10 electrons. So both Na plus and F minus are isoelectronic. You don't really need to know this, I don't think so, but it's a really nice word. Isoelectronic have the same electron. However, Na plus has more protons, so stronger So diagram B, both Na plus and F minus are isoelectronic, have the same electron arrangement.